We are looking at graphing, and college algebra does a lot of graphing in this course. And so looking at the problem in front of you, you should be able to answer these types of questions. And so this is stuff that we had looked at the end of last week. So I'm going to give you a couple minutes and see how much you can do of this problem, and then we'll talk about it. So I'm going to pause the recording, but if you're watching this not live, then you can also pause the recording and try this on your own. So let's go through the problem now. You've had a chance to work on it. The first part says find f of 0 and f of 6. So looking at this, you need to know what this represents. And so f of 0, this is saying that we're going to find y, maybe. Let me just pause for a second while I get this working. Of f of 0, what this is saying is our x value is 0. And we want to find out what is y. So when x equals 0, our y value here is also 0. And so y is 0. So this f of 6, we're looking at when x equals 6, we want to know what y is. Excuse me. So if I look down here or over here, when x equals 6, my y value is 0. So find f of 2 and f of negative 2. So f of 2, when x equals 2, look at the graph and see what your y value is. And your y value there is negative 2. So f of negative 2, when x is negative 2, y is 1. So part C says, is f of 3 positive or negative? Well, if we look at when x is 3, oops, that's not 3. When x is 3, we want to see, is this below or above the x-axis? And that will tell us, is that a positive or a negative number? Well, the graph here falls below the x-axis, and so f of 3 is a negative number. So same sort of question, except now we're looking at negative 1. Is f of negative 1 positive or negative? So going to the graph at x equals negative 1, this is falling above the x-axis, and so this is a positive value. So for what values of x is f of x equal to 0? So looking at this, that's basically telling us what values are our y values 0. Our y values are 0 when we're hitting the x-axis. And so places where it hits the x-axis is at 0, 0, at 4, 0, and at 6, 0. So for values of x, we got x equals 0, 4, and 6. So part F says, for what values of x is f of x less than 0? So this tells me I'm looking for, when is my y values less than 0? Well, if you look at the graph, y is less than 0 below this x-axis. And so looking at this, this is below the x-axis. This is starting at 0 for x and ending at 4 for x. And so in this piece, we're going to say that this is when x is bigger than 0, but less than 4. The domain, that's where we're looking at values, our x values that the graph is hitting. And so because there is a solid point on each end, that tells me that graph is not continuing in that direction, stopping there. And so the smallest x value I have is -4, and it was a solid point there, so I'm including it. I'm going to write it in interval notation. So -4, comma, and we're ending when x is 6. Again, it is a closed circle, so we're including it, so we're going to put a bracket there. You could have written this as -4 is less than or equal to x, is less than or equal to 6. They mean the same thing. For our range, those are all the y values that the graph is hitting. And so if you look at all the y values the graph is hitting, I always go from smallest to largest. So the smallest point that graph is hitting when y is -2. And the highest y value that we're hitting is when y is 3. And so for our range, this is the only time we use y values when we're looking at interval notations. But we're going from -2 to 2, not -2 to 2, -2 to 3, and including. Another way to write that was -2 is less than or equal to y is less than or equal to 3. What are the x-intercepts? Well, that's the same thing as when f of x was 0. So my x-intercepts were the points where it's crossing or touching the x-axis. And so again, this is going to be x equals 0, 4, and 6. The y-intercept, that's where it's crossing the y-axis or touching the y-axis. That's at 0, or the point 0, 0. How often does a line y equals -1 intersect the graph? So y equals -1 is a horizontal line, and y equals -1. So if we look at the graph, y equals -1. Looking at how many times this crosses the graph, we have 1 here and 1 here. So we have that this crosses 2 times. How often does the line x equals 1 intersect the graph? Well, x equals 1 is a vertical line going through 1. So find where 1 is. X equals 1 is here. And so that vertical line intersects once. For what values x does f of x equals 3? Okay, so this is where our y value is equal to 3. One second. Now we are looking at for what values of x does f of x equals 3. So f of x equals 3, that is saying that my y value is 3. So the y value is 3. What I tend to like to do is I like to put a vertical or horizontal line at y equals 3 and see where it's crossing, and those are the graph, and those are the x values that give me the y value that is 3. And so if I look at y equals 3, notice there's only one point on the graph where that is touching, and that is when our x value is 5. So our y value is 3 when x equals 5. And then the last one is similar. So for what value of x does f of x equals -2? And so in this case, we're looking at when is what x value give us a y value of -2, when there's only one spot again where this is crossing the graph. And so this is when x equals 2. So let me see if there's any questions on any of that. And then we will go to the next problem you guys looked at. So you were looking at this problem, f of x equals x squared plus 2 all over x plus 4. And we wanted to know is x equal, or sorry, is the point 1/3 on the graph? We know in this case that our x value is 1. We know that our y value is 3/5. And we want to go in here and plug in our values. And so if we do that, we have is 3/5. Is this equal to, let's go in and plug in 1 wherever we see an x. So 1 squared plus 2 all over 1 plus 4. Well, 1 squared is 1, and then 1 plus 2 is 3 in our numerator. And our denominator, we have 1 plus 4, which is 5. And so this checks out. And so yes, 1 3/5 is a point on the graph. So if x equals 0, what is f of x? What point is on the graph? So if x equals 0, so how we could write that is, let's find f of 0. So we're going in here, wherever we see an x, we're plugging in 0. So we got 0 squared, which is 0, plus 2. So we have 2 all over 0 plus 4, which is 4. And so this reduces to 1/2. So the point on the graph is going to be 0, 1/2. So if f of x equals 1/2, what is x? What points are on the graph of f? So this is saying when f of x is 1/2, so we're going to set our equation and have 1/2 equals this x squared plus 2 all over x plus 4. So we want to figure out what x is, or there could be multiple values of x that give us back a y value of 1/2, but we want to find those. Looking at this is a rational equation. We've dealt with those before. We can clear the fraction by multiplying both sides by the LCD. If I look at the least common denominator, that's going to be 2 all times x plus 4. So when I multiply it on the left-hand side, the 2's cancel. And that was the whole point of doing that, multiplying by the LCD. So we're left with just the 1 times x plus 4, which is x plus 4. This is equal to, so when we multiply the LCD on the right-hand side, our x plus 2's cancel, or not x plus 2, x plus 4's cancel. And we're left with this parentheses x squared plus 2 and parentheses times 2. So when I'm bringing it down, I'm going to distribute this 2, if that's okay. So distributing that 2 inside that parentheses, we're left with 2x squared plus 4. So look at what type of equation we have. It's quadratic. So we want to get everything to one side of the equation, set it equal to 0. So if I subtract x on both sides and subtract 4 on both sides, I get 0 is equal to 2x squared minus x, and my 4's cancel. So solving this, we're going to factor out an x, which gives me 2x minus 1. Set each factor equal to 0. So this occurs when x equals 0 and when 2x minus 1 equals 0. So solving for that 2x minus 1 equals 0, add 1, and then divide by 2. So we get 2x equals 1, x equals 1/2. So there's two values of X that would give us back a Y value of 1/2. It wants to know what are the points. So the point is going to be 0 when X is 0, Y is 1/2. And when X was 1/2, Y is also 1/2. The domain, when we're looking at the domain of a function, not the graph, we want to look at our trouble spots. Trouble spots are values that are going to give us negative underneath an even powered radical, values that set the denominator equal to 0. When we get into logarithms, we have to worry about that. When you get into trigonometric functions in a trig class, you're going to have to worry about domain 2. But for right now in our class, we're basically worried about values that set the denominator equal 0 or negatives underneath the even powered radical. So we have here a rational function. We're worried about when is that denominator equal 0. So we know that X plus 4 cannot equal 0. So X cannot be -4. So there's a couple of different ways that we could write this. We could write this in interval notation. So we have -infinity all the way to -4, not including. So we have a parentheses there, union -4, but there's a parentheses around that -4 again, because it's not including to infinity. You might see that sometimes the homework program uses sup builder notation, and they might have just left it with that curly bracket X with that vertical line, which means such that. So X such that. In this case, you would just put that X cannot equal -4. Any questions on that? So list the x-intercepts of any of the graph. X-intercept, that is when our Y value is 0. This was part D. So part E, we're looking at 0 equal to x squared plus 2 all over x plus 4. If we multiply both sides of our equation by x plus 4 to clear our fraction, we get that 0 is equal to our numerator, x squared plus 2. So solving for x there, we could subtract 2 on both sides and use our square root property. But I noticed that I have x squared equals -2. So I noticed that this is not going to give me back a real number. If you had done this, this would have been plus or minus I root 2. This is not real. So since we didn't get a real number back when we set that equation equal to 0, this has no x-intercepts. And then the last one was, what is the y-intercept, if any? So the y-intercept, again, our equation was f of x equals x squared plus 2 all over x plus 4. The y-intercept occurs when x is 0. And so we want to plug in 0 wherever we see an x in here. Oops. And so if I look at f of 0, I got 0 squared plus 2 all over 0 plus 4. So this is 2 over 4, which is 1/2. So there is a y-intercept. And if it wants it as a point, our y-intercept is 1/2, 0. Okay. So hopefully you were able to figure those out. So one other problem I pulled from this section, which I thought looked really good, and it really shows me that you understand what it's asking for. And so we looked at properties of functions and how we can write it. This part A says that we're looking at f plus g of 2. So we're looking at both of these graphs. We're given the graph of g of x, which is the blue graph, that parabola there. And we're given the graph of y equals f of x, which is like a purplish pink in there. That's a line. And so part A, it is asking us to find f of 2 plus g of 2. Well, let's look at f of 2. So f of 2, we're looking at when x is 2. When x is 2, what is that y value? Well, on this graph, that y value is also 2. So f of 2 is 2 plus g of 2. So g of 2, we're looking at our graph g of x, that parabola, when x is 2, that y value on the graph is 1. So we have 2 plus 1, which is equal to 3. I'm going to skip some of them. So f plus g of 4 is similar. Let's look at C. So f minus g of 6. So this wants us to look at f of 6 minus g of 6. So looking at the graph, when x is 6, the y value there is 0 minus g of 6. So looking at the graph, g of 6, we have here 1. So 0 minus 1. So that gives us back negative 1. So E, which says, another way to write this is we're looking at what is f of 2 and multiplying it to what is g of 2. So f of 2, we already looked at this, f of 2 when x is 2, the f of 2 is also 2. So this is 2 times g of 2. G of 2 was 1. So we have 2 times 1, which is 2. One more. F divided by g of 4 is the same thing as looking at f of 4 divided by g of 4. So looking at when x is 4, f of 4, that is giving us a y value of 1 all over g of 4. So g of 4, that y value is negative 3. So this would be equal to negative 1/3. Okay, so that was just kind of a review of stuff that was on 3.2, properties of graphs or functions. So let's look at 3.3. Let me change my page.